Oh, who exactly is this dude? This is an old dude who lived a long time ago by the name of Plato. Plato is considered to be the founding father of Western thought, and he came up with one of the theories that he came up with, one of the biggest theories he came up with was the theory of forms. His concept is that we live in an imperfect world. We look at a circle, any sphere, and it's imperfect. There's going to be some flaw in it. But he proposed that there was a perfect circle, a perfect sphere. He took this further, said there was a perfect tree, and this tree that we see is an imperfect tree. But there is a perfect tree. Now, in science today, we don't talk about perfect trees, but we do talk about a perfect sphere. And we do talk about things like ideal gas laws. The laws that we say that govern the behavior of gas, only truly apply to the ideal gas, or rather a gas that doesn't exist in this world. But all of the other gases have these little things like the second law of thermodynamics, like friction, like things that we can't predict, that cause them to behave differently from how the law dictates. But the ideal gas would follow the law all the time. And we don't talk about the perfect tree, but we do talk about a theoretical tree. When scientists and botanists need to discuss a theory, we create what is essentially a perfect tree, a tree that always follows the laws we want it to. And then we create a simple pattern of behavior for this tree. And this theoretical tree, or this perfect tree, will always follow that pattern of behavior. Then we hold this perfect tree up to a real tree. And where they differ is where we learn things. Why isn't this tree sticking to the behavior that's defined by the perfect tree? Or rather, as we say, by my theoretical tree. And when we see the real tree differing from the theoretical tree, we change our theory. And our theory gets better. And our theoretical tree gets actually closer and closer to being a perfect tree. Now, one place that we do actually talk about perfect things is spheres and surfaces. Have any of you ever seen a project yet? Something was traveling along a frictionless surface. When we talk about a frictionless surface, we are talking about Plato's perfect surface, a surface that is perfectly smooth. Now, in real life, there is no such thing as a frictionless surface. You can get very low friction on ice or on other surfaces, but there's no such thing as a perfectly frictionless surface. But to learn to use the math that you need to build roads, to build buildings, you can't give a first-year physics student a complicated problem with all of its gross imperfections from the real world. You have to give them a simplified problem to learn. Just like Plato did, you have to give them a perfect surface or a perfect form.